We're in Unit 3, Lesson 5 today, Chapter 7, Section 5 out of the textbook, and talking about properties of logarithms. We've only got one content standard for this lesson, create equations and inequalities in one variable and use them to solve problems, and one mathematical practice to look for and express regularity in repeated reasoning. In previous lessons in this unit, we've evaluated logarithmic expressions and we've solved logarithmic equations. And in this lesson, we're going to simplify and evaluate expressions using the properties of logarithms, and we're also going to solve logarithmic equations using the properties of logarithms. So our first property of logarithms is the product property, which means multiplication. So for example, if I have the log, no matter what base it is, of two things that are multiplied together, that's equivalent to the log, to the sum of those two, the log of those two expressions. So basically, here's your concept. Log base x of AB is log base x of A plus log base x of B. So in our first example, we're going to use the concept that log base 5 of 2 is approximately equal to 0.4307 to approximate the value of log base 5 of 250. So the first thing we want to look at is that log base 5 of 250, or the number 250, is 2 times 125. And 125 is 5 to the third power. So we're looking at log base 5 of 5 to the third power times 2. So we're going to use our product property to separate these two things into the sum of the two different logs, log base 5 of 5 to the third and log base 5 of 2, and we're going to add them together. So in order to evaluate this first log, we need to think about 5 to what power would give us 5 to the third. Well, 5 to the third would give us 5 to the third, so this expression right here is just 3. And this expression, they told us, is about 0.4307. So we're just doing 3 plus that number, and so our answer is 3.4307. All right, check your progress for example 1. If log base 2 of 3 is about 1.5850, what's the approximate value of log base 2 of 96? And so moving on to the next screen for our answer, we get an answer of D 6.5850, which tells me, remember that 3 times 32 would give us 96, and 32 is 2 to the 5th power, and so log base 2 of 96 is the same as log base 2 of 2 to the 5th plus log base 2 of 3. We know log base 2 of 3 is 1.585, and log base 2 of 2 to the 5th. 2 to what power gives me 2 to the 5th? Well, that's 5. So this is just 5 plus the thing they gave us, which was 1.585. I'm going to be kind of sloppy right here, just trying to write pretty quick. And that obviously gives us D 6.585. The quotient property, so division. If we have log base x of a divided by b, that becomes subtraction. So log base x of a minus log base x of b. So we're going to check this property out in a word problem. It says the pH of a substance is defined as the concentration of hydrogen ions, H+, in moles. And moles is in a measurement form for substances in science. It is given by the formula pH equals log base 10 of 1 over H+. Find the amount of hydrogen in a liter of acid rain that has a pH of 5.5. So to set up our equation, we're going to write the equation with the value that they gave us. So the equation was pH equals log base 10 of 1 over H, and the pH was 5.5. So log base 10 of 1 over H is the same as log base 10 of 1 minus log base 10 of H. Log base 10 of 1, 10 to what power gives us 1? Well, that's 0. 10 to the 0 power is 1. So 0 minus log base 10 of H gives us 5.5. So we're going to add this to the left side and subtract 5.5. And we'll see what that is on the next screen. So it says that 5.5, log base 10 of H is negative 5.5, which means that 10 to the negative 5.5 power is H plus, which is the number of hydrogen ions. And plugging 10 to the negative 5.5 power in our calculator gives us about 0.0000032 moles of hydrogen in a liter of this rain. Just checking our answer now, if we plug 10 to the negative 5.5 in, and then simplifying this out using the quotient property for logs, we get 0 minus negative 5.5, which is obviously positive 5.5. The answer checks out. Here's a check your progress problem. This time we're looking at the amount of hydrogen in a liter of milk, and the milk has a pH of 6.7. And so solving this problem, we get an answer of C.00000020 moles of hydrogen in a liter of milk with a pH of 6.7. Okay, for example 3, we're going to look at a power property of logarithms. Log base 2, or let's look up here, log base b of m to the p power. Remember, whenever we deal with logs, the exponent comes down in front, so this is equal to p times log base b of m. So they're going to tell us that log base 5 of 6 is about 1.1133. And we're going to need to use that to approximate the value of log base 5 of 216. So the first thing that we should recognize is that 216 is 6 to the third. So log base 5 of 6 to the third, bring the 3 down in front. So we're just doing 3 times this number that they gave us, which is 3.3399. And that's our answer. Check your progress. 6 to what power gives us 1296? If you think about that, you'll be able to get this answer pretty easily. It turns out that 6 to the third power, 6 to the fourth power is 1296. So we're just doing 4 times the 1.2925, and we get 5.17, choice C for our answer. For example 4, we're going to apply all the properties that we've thought about together in this lesson to solve this equation. We have 4 times log base 2 of x minus log base 2 of 5 equals log base 2 of 125. So the first thing I can do is take this 4 and bring it back up here as an exponent. And then because I see that I have 2 logs that are subtracted, I know that that's the division. It's a fraction. So that would be x to the 4th divided by 5. And then because I have simplified these down to just a single log and a single log, and they both have the same base, I can ignore the logs and just use the expressions. X to the 4th over 5 is 125. I'm going to multiply both sides by 5. Then I'm going to take the 4th root, and I get the number 5. Technically, if you take the 4th root of 625, you would also get negative 5. But you need to remember that this answer, it doesn't count because you can never have a negative answer for x when you're dealing with log equations. You can only have positive answers. So negative 5 is called, let me put this out in a text box, x equals negative 5 is an extraneous solution. So it doesn't actually count. We don't consider it. We only consider the answer x equals 5. In order to check our work, we can just plug our answer back in. 5 to the 4th minus log of 2 of 5. 5 to the 4th divided by 5 is 5 to the 3rd. And yes, in fact, 5 to the 3rd is 125. Our answer checks out. We've got to check your progress problem for this. 2 times log base 3 of x minus 2 minus log base 3 of 6 equals log base 3 of 150. And once you have your answer, go on to the next screen. And this time we see our answer is 32. Okay, so that brings us to the end of Unit 3, Lesson 5, looking at the properties of logarithms. Remember, we learned 3 properties in this lesson. The property of a product, so multiplying 2 numbers together, what happens with a log. We learned division, if you divide 2 expressions, what happens with the logs. And if you have powers with logs, what happens and how can you simplify those logarithmic expressions. All right, so now head on back to the classwork or the homework or whatever you need to get done for this lesson.